My dear friends, my name is Abhishek and you are watching Maths Magic channel on YouTube. Today we are going to start chapter number 2 of standard 10th, that is polynomials. In this chapter, what we are going to learn, and first of all the question is what is polynomial. So whenever an expression is having single term, it is called as the monomial. Whenever any expression is having double terms or two terms with addition, subtraction, multiplication or division, it is called as the binomial. Whenever any expression is having three terms, it is called trinomial. And whenever an expression having two or more than two terms, it is called as the polynomial. Even trinomial is coming under polynomial, but we are just discussing it for detailed understanding. Then types of polynomials according to the degree. These are types of polynomials according to the number of terms. Now according to the degree, whenever an expression does not contain any variable x, y, z or a to z, it is called constant polynomial. Whenever a variable is present with no exponent, it is called degree 1 polynomial. Whenever any variable with exponent as 2, it is called degree 2 and polynomial. And whenever any polynomial with degree 3 or exponent 3 is present, it is called the cubic polynomial. So this is what we are going to study in this chapter. Now we are moving to the topic number 2.1, that is introduction. What they have discussed in the introduction, that we have already studied polynomials in one variable in 9th standard. We have studied in 9th standard that polynomials in one variable we have already studied. Now in the next topic they are telling us that p of x is a polynomial in x. The highest power of x in p of x is called the degree of the polynomial. What they are telling us, that maximum power present in the expression is called as the degree of the polynomial. Here for example, they have given us that 4x plus 2 is a polynomial in the variable x of degree 1. Here x is the variable, 4 is the coefficient, and no exponent is there. It means that 1 is always present whenever no exponent is given. Therefore here degree of the polynomial is 1. In the next example, 2y square minus 3y plus 4. Here maximum exponent is 2 and the variable is y, and the coefficient is 2 and minus 3 in the variable y. So maximum exponent is 2, so the degree of the polynomial is 2. In the next expression, 5x cube minus 4x square plus x minus root 2, here maximum exponent is 3, so degree of the polynomial is 3. Next example is 7u6 minus 3 3 by 2 u raised to 4 plus 4u raised to 2 plus u minus 8 is a polynomial in the variable u of degree 6. Here u is the variable and 4, 1, here nothing is present, it means 1 is present. Here minus 3 by 2 and 7 all are coefficient. 7 minus 3 by 2 is coefficient, 4 is coefficient, 1 is coefficient, and 6 is the exponent, 4 is the exponent, 2 is the exponent, and 1 is the exponent. Here nothing is present, it means 1 is there. So maximum exponent is 6, so 6 is the degree of the polynomial. Expression like 1 upon x minus 1, root x plus 2, and 1 upon x square plus 2x plus 3 etc. are not polynomials. Why they are not polynomials? Because the condition for polynomials is the exponent should be positive. It should never be negative. When we put x minus 1 in the numerator, they will be having minus 1 as the exponent. Here also x square plus 2x plus 3, when put into the numerator instead of denominator, when we change the place, the minus 1 will be there in the exponent. Here it is half 1 by 2, x raised to 1 by 2, that is root x. So these are not polynomials. Then we are discussing about the linear polynomials. Whenever a expression having a variable and variable has a power or exponent as the 1, it is called as the linear polynomial. A polynomial of degree 1 is called as the linear polynomial. Here maximum exponent, here no power is present, it means then 1 is always present. Here x is the variable and 1 is always present. If exponent is not given, it means that 1 is the exponent. So this is called as the linear polynomial. Here next expression is root 3x plus 5. Here x is the variable and exponent is not present. Whenever exponent is not present, it means 1 is present. So this is linear polynomial. Next expression y plus root 2. Here y is variable and exponent is 1. It means linear polynomial. Next is x minus 2 by 11. Here x is variable and exponent is 1. It is called linear polynomial. Next example is 3z plus 4. Here z is the variable and exponent is 1. It is called linear polynomial. Then the next example is 2 by 3 u plus 1. Here u is the variable and 1 is the exponent. So this is linear polynomial. So these are all the examples of linear polynomials. Then we are going to discuss that polynomials such as 2x plus 5 minus x square, x cube plus 1 etc. are not linear polynomials. Here variables with no exponent is present and variables with 2 as exponents are also present. Variables with 3 as exponent are also present. So these are not linear polynomials. So what kind of polynomials are they? They are discussing as whenever a polynomial of degree 2 is present, it is called as the quadratic polynomial. Whenever any expression is having 2 as the exponent, it is called as the quadratic polynomial. The quadratic polynomial name comes from the word quadrat, which means square. So examples of quadratic polynomials are 2x square plus 3x minus 2 by 5. Here 2 is exponent. Here maximum exponent is 2. So it is called as the quadratic polynomial. Next example is y square minus 2. Here maximum exponent is 2. So it is also quadratic polynomial. Then the third expression is 2 minus x square plus root 3x. Here maximum exponent is 2. So this is quadratic polynomial. Next example is u by 3 minus 2u square plus 5. Here maximum exponent is 2. So this is quadratic polynomial. The next example is root 5 v square minus 2 by 3 v. Here variable is v and the maximum exponent is 2. So this is quadratic polynomial. Then the next example is 4z square plus 1 by 7. Z is the variable and 2 is the maximum exponent. So this is the quadratic polynomial. So these are some examples of quadratic polynomial. Here one condition is given that whose coefficients are real numbers. Here coefficients are real numbers. Real numbers means root can be also possible in the quadratic polynomials. General form of quadratic polynomial means the expression having 2 as the exponent. So the general form of quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Then we are discussing a polynomial of degree 3 is called a cubic polynomial. Whenever 3 is present as exponent in a given expression, it is called as the cubic polynomial. Examples of cubic polynomials are 2 minus x cube. Here x is variable and 3 is exponent, so this is cubic polynomial. Then x cube, x is variable and 3 is exponent, so this is cubic polynomial. Then root 2 x cube. Root 2 is real number or irrational number, you can say, and x is variable and 3 is exponent, so this is cubic polynomial. Then the next example is 3 minus x square plus x cube. So here x is the variable and 3 is the maximum exponent, so this is cubic polynomial. Next example is 3x cube minus 2x square plus x minus 1. Here x is variable and 3 is the maximum exponent, so this is cubic polynomial. So general form of cubic polynomial is ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a is not equal to 0. Now they are giving us one of the examples of polynomials, that is x square minus 3x minus 4. They are telling us to put 2 instead of x. Wherever x is present as the variable, we have to put the value 2 instead of x. So putting x is equal to 2 in the polynomial, we get polynomial of 2, that is 2 square minus 3 into 2 minus 4, that is 2 square is 4, 3 into 2 6. Here minus sign is present, so minus 6 and minus 4, minus 6 minus 4 minus 10 plus 4, that is minus 6. So minus 6 is the answer. The value minus 6 obtained by replacing by x by 2 in the x square minus 3x minus 4 is the value of x square minus 3x minus 4 at x is equal to 2. Whenever we put x is equal to 2 in the equation x square minus 3x minus 4, the answer will be minus 6. So this statement is deducing it. Similarly, p of 0, whenever we put in the polynomial p of x, instead of x we put 0, what is the answer we will get? Here x square is there, so instead of x we will put 0 square, that is 0. Here minus 3x is there, instead of x we will put 0, so here 0 square minus 3 into 0, that is 0. Here also 0 and minus 4, so minus 4 is the answer. So they are giving final statement that if p of x is a polynomial in x and if k is any real number, then the value obtained by replacing x by k in p of x is called the value of p of x at x is equal to kn is denoted by p of k. What they are telling, whenever any polynomial is given and with any variable, if you put k that is any real number, then you will get some answer. That answer is called the value of p of x at x is equal to k, or any real number. It is denoted by p of k. Then they are discussing about the answer coming as the 0. What we will put instead of x in the given equation so that the answer will become 0. To make the answer come as the 0, or to bring the answer as 0, we will put instead of x as the variable, we will put minus 1 instead of x. That is, putting x is equal to minus 1, we will get in the polynomial minus 1 whole square, that is then minus 3 into minus 1 minus 4, minus and minus plus, so plus 3, this is minus 4, and minus 1 whole square, that is plus 1, plus 1 plus 3, that is 4, 4 minus 4 is 0. So when we put x is equal to minus 1 in the equation or the polynomial x square minus 3x minus 4, we are getting answer as the 0. Again we are putting x is equal to 4, then we will get in the polynomial 4 square minus 3 into 4 minus 4. So 4 square is 16, 4 3s are 12, here minus n is present, so it is minus 12, here minus n is present, so it is minus 4, 16 minus 12 minus 4, minus 12 minus 4, that is minus 16, 16 minus 16 is 0. So our final answer is 0 in the polynomial when we put x is equal to 4. So they are giving us the statement as p of minus 1 is equal to 0 and p of 4 is equal to 0. So minus 1 and minus 4 are called, so minus 1 and 4 are called as the zeros of the quadratic polynomial x square minus 3x minus 4. Quadratic polynomial, here exponent is 2, so it is quadratic polynomial. So they are giving the general statement that more generally a real number k is said to be a zero of the polynomial p of x is p of k is equal to 0. We can get 0 if we put polynomial is equal to 0, that is whole polynomial equation. In class 9th we have studied how to find zeros of the linear polynomial. For example, if k is a zero of the polynomial p of x is equal to 2x plus 3, then p of k is equal to 0. Instead of x we are taking k, and to find the 0 we will equate 2x plus 3 with 0, so 2x, and instead of x we are putting k, so 2k plus 3 is equal to 0. Therefore k is equal to this plus 3 will go into right side, it will become minus, plus then will become 9 minus, and this 2 is in multiplication, so 2 will go in denominator, so k is equal to minus 3 by 2. So in general, if k is a 0, p of x is equal to ax plus b, then p of k will be ak plus b, or k is equal to minus b by a. In general form we can write it as minus b by a, or coefficient constant minus constant term upon coefficient of x. Thus the 0 of a linear polynomial is related to its coefficient. Then they are discussing same way we can obtain for quadratic and cubic polynomials. This we will discuss in the next video, and in the next video we are also going to study about the division algorithm for polynomials. So this is the introduction of the chapter number 2. Thank you and have a nice day, my dear friends.